Hello students, welcome. Previously, lesson 5 from 2 to week 3, we were dealing with coordinate bond or dative bond, and we said a coordinate bond or dative bond is a special type of covalent bond in which the paired share of electrons is only contributed by only one of the atoms forming the bond. Examples of substances that have coordinate bond include ammonium ion, we have said hydroxonium ion, phosphonium ion, and also carbon 2 oxide. So today, lesson 6, we want to proceed to the structures of covalent bond or covalent bonding. And we are saying substances which have covalent bond have either molecular structure or giant covalent or giant atomic structure. So that we are saying when we are dealing with ionic bonding, we were only having one type of a structure, that was giant ionic structure. But when we're talking about covalent bonding, it is having two structures. Some of the substances are having molecular structures, some others are having giant covalent or giant atomic structure. So in our class today, we'll be just dealing with the first type of structure of covalent bond, that is molecular structures. We're saying most molecular substances are gases or liquids at room temperatures. Some examples of molecular substances include sulfur, sugar, iodine, naphthalene, sulfur peroxide, and many others. So in the molecular structure, we're seeing atoms or the atoms forming the molecules are held together by strong covalent bonds, but the molecules themselves are in turn held together by weak van der Waals forces in a regular pattern. This pattern repeats itself many times in all directions, resulting to the formation of a molecular structure. For example, we are having here the structure of iodine molecule is shown below. When we check this structure, the atoms in iodine molecule are two iodine atoms. We are having two iodine atoms. So that means these two iodine are held themselves by a covalent bond. So we're having next again the molecules of iodine are held together by weak van der Waals forces. When you check this structure, we are having iodine molecule and this is another iodine molecule. So these two iodine molecules are held together by weak van der Waals forces. And we're talking about these forces that we have there. Those are weak van der Waals forces. So, but when we're talking about the atoms forming the molecule, the atoms forming iodine molecules are held together by a covalent bond. You see there, we're having covalent bond. That shared part, we're having covalent bond. Each iodine atom is contributing one electron to be shared. So we are having maybe this iodine is having one cross, is contributing one cross, and the other iodine is contributing one dot. So here we are having covalent bond. So the atoms forming the molecule are held together by strong covalent bond, but the molecules of iodine themselves are held together by a weak van der Waals forces. Next, we want to go to physical properties of molecular substances. We are going to use this table here. We are going to talk about the solubility in water, the molecular mass, we are having the melting and the boiling point, their electrical conductivity. So we are going to start the first one, that is electrical conductivity. And when you check the table, we are having poor. That means molecular substances are poor conductors of heat and electricity. The reason why they are poor conductors of heat and electricity is that because they lack the localized electrons or mobile electrons in their structure. So next we are going to talk about melting and boiling point. The way we see from the table, molecular substances have low melting and boiling points. Reason? This is because the atoms forming the molecules are held together by strong covalent bonds, but the molecules themselves are held together by a weak van der Waals forces, which requires little energy to break. For that reason, molecular substances are having low melting and also boiling points. So next we are saying the melting and the boiling points of molecular substances increase with increase in the relative molecular mass. Some substances, however, display a disparity. For example, so number one, we are told water, which is written H2O with a relative molecular mass of 18, has a higher melting point of 0 degrees Celsius than hydrogen sulfide with a relative molecular mass of 34 and a melting point of negative 85. We are supposed to explain the reason. In this point, we said the melting point and the boiling points of molecular substances increase with increase in the relative molecular mass. For example, here, the relative molecular mass of water is 18 and that of hydrogen sulfide is 34. So we are expected hydrogen sulfide to have high melting point compared to water because hydrogen sulfide is the one that's having a higher relative molecular mass. So we expected hydrogen sulfide to have a higher melting point than the water, which is having a small relative molecular mass or a lower relative molecular mass. So when you talk about something like this, what we are talking about will be the intermolecular force. We are supposed to check the intermolecular force for water and that other side for hydrogen sulfide. So I say this because the molecules of water are held together by a hydrogen bond, while the molecules of hydrogen sulfide are held together by weak van der Waals forces. Therefore, hydrogen bonds are stronger than weak van der Waals forces. So therefore, water will be having a higher melting point than hydrogen sulfide. That will be the reason. So the second example that we're picking there will be dimethyl ether, which is written C2H6O boils at negative 24 degrees Celsius, while ethanol, which is written C2H5OH boils at 78.2 degrees Celsius. But when you see, both of them have the same molecular mass. The reason why they're having the same molecular mass is that because they have the same number of atoms. Like here, we have 2 carbon, we have 6 hydrogen, we have 5 here plus 1 hydrogen, those are 6, 1 oxygen and 1 oxygen. So they're having the same molecular mass. So we expected if they have the same relative molecular mass, we expected them to have the same boiling points. But dimethyl ether is having negative 24 degrees Celsius, while ethanol is having 78.2 degrees Celsius. The same case here, we will be just checking the intermolecular forces of attraction holding the molecules of dimethyl ether and also ethanol. So we're saying this because molecules of ethanol are held together by a hydrogen bond, while molecules of dimethyl ether are held together by weak van der Waals forces. So we're saying hydrogen bond or hydrogen bonding are stronger than weak van der Waals forces. The third properties of molecular substances, we want to talk about solubility in water. We are saying most molecular substances are insoluble in water. However, some molecular substances such as sugar, ethanol, and ethanoic acid are soluble due to the presence of hydrogen bonding as their intermolecular force. So we're saying most of them are insoluble in water, like sulfur. Sulfur is a molecular substance. Naphthalene is a molecular substance. All of those ones are insoluble in water. But we are having some molecular substances like sugar, ethanol, and ethanoic acid, which are soluble in water. And the reason is that they have hydrogen bonding as their intermolecular force. So next, we are going to go to hydrogen bonding. So we start first of all, what is hydrogen bonding? And we are saying this is an intermolecular force of attraction in which the electropositive hydrogen atom of one molecule is attracted to an electronegative atom of another molecule. For hydrogen bond to be formed, one of the atoms must be hydrogen, and it is represented by a dotted line. A hydrogen bond is stronger than weak van der Waals force, but weaker than a covalent bond. You have to know that. So when you're having covalent bond with hydrogen bond, covalent bond is stronger than hydrogen bond. When you're having hydrogen bond with weak van der Waals forces, hydrogen bond is stronger than the weak van der Waals forces. So example, illustrating hydrogen bonding is water. So let us see the structure of water. So we're saying in water, the electropositive hydrogen of one molecule is attracted to the electronegative oxygen of another molecule. That will give us now coordinate bonding. So we're saying this structure that we see there is the structure of water. Water is written H2O. That means we have one oxygen linked into 2 hydrogen, like that. So this is electropositive hydrogen, and here we're having electronegative of oxygen. So what will happen is that if we're having another molecule here, and that molecule is like this, hydrogen here, then I'm having another hydrogen. So these two hydrogen will be linking to one oxygen here, like that. So if I take this oxygen here, which is electronegative, then I link with this hydrogen, which is electropositive, the type of bond that I'm going to get there will be hydrogen bonding, because we're having here electropositive hydrogen of one molecule. That's the water here that we have. The water that we have here of one molecule is attracted to an electronegative oxygen of another molecule, and this is another molecule for water. That's where we're going to get the hydrogen bonding. If we check this structure here, we're having one molecule of water there and another molecule of water here. So we have here electropositive hydrogen of one molecule here getting attracted to an electronegative atom, which is oxygen, of another molecule, which is water there. So the type of bond that we're having there will be hydrogen bonding. But when we talk about the bond that we have here, this bond here between this hydrogen and oxygen, that's covalent bond. This oxygen with that hydrogen is covalent bond. This hydrogen with this oxygen here, that's a covalent bond. This oxygen with this hydrogen, that's a covalent bond. But coordinate bond will be existing when the electropositive hydrogen is attracted to an electronegative oxygen of another water molecule. So this is a separate water molecule, this is a separate water molecule. So the intermolecular force of attraction holding those molecules together is what is known as hydrogen bonding or hydrogen bond. So we're to note van der Waals forces. What are van der Waals forces? We're saying van der Waals forces are weak forces of attractions between molecules or atoms which exist only when the particles are close together. When the particles are close together. Learners, that's the end of our video today. Thank you for watching.